Right now, as you watch this, a rock from another star system could be crossing our solar system at tens of kilometers per second, and we could still lose it after just a few nights. What if I told you 3I Atlas is gone? Doesn't mean it vanished like magic. Sometimes it means we literally can't predict where to point a telescope anymore. Stay with me, because by the end of this video, you'll understand the three real reasons an interstellar object can disappear, and the one twist that would be the most embarrassing outcome of all. This sounds insane. The universe hands us a once-in-a-generation visitor, and then it's just gone. But here are the impossible facts that make it totally believable. A real object can be so faint, it's basically invisible outside big surveys. If you only track it for a short time, your predicted position balloons into a massive uncertainty region, like losing a speeding car in fog after seeing it for 1 second. And interstellar objects don't behave politely. Some outgas, fragment, or brighten and fade in ways that mess with our models. So what happened with 3I Atlas? Did it break apart, slip into a blind spot, or was it never what we thought it was? To get this, you need the normal discovery pipeline. Surveys like Atlas repeatedly photograph the sky and look for dots that move. Most moving dots are routine: asteroids, comets, satellites, space junk. A true interstellar candidate is special because its orbit is hyperbolic, not bound to the sun, meaning it came from outside and will leave again. The Minor Planet Center collects observations and computes orbits, and that's the system that turned the first interstellar discoveries into real science. 1I Oumuamua in 2017 and 2I Borisov in 2019, MPC and NASA summaries. This is where things get strange, because an orbit is not a photograph. An orbit is a best-fit math solution based on limited data. If your observation arc is short, hours or a couple nights, your orbit fit can be fragile. One tiny error, one misidentified dot, one unmodeled push from outgassing, and your predicted location later can be off by a lot. So when people say it's gone, it often means something painfully unromantic. We don't know where to point the telescope with high confidence anymore. Subscribe if you like space mysteries with real receipts, because the next part is the detective breakdown astronomers use when something vanishes: fading, math uncertainty, or physical change. And the final twist that turns a cosmic visitor into a simple data mistake. Stay with me here. Let's tell this like detectives. In 2017, astronomer Robert Warwick spotted Oumuamua in Pan-STARRS data, and the world realized interstellar objects aren't theoretical. They're real. NASA MPC. In 2019, Gennady Borisov found 2I Borisov, and this time it looked like a classic comet with gas and dust. NASA MPC. Those two discoveries taught astronomers a brutal lesson. The first days matter most. You need rapid follow-up because geometry changes fast and objects fade. Now fast forward to the kind of 2026 headline you're seeing: 3I Atlas is gone. If that's true, it likely followed a familiar pattern: initial detection, early orbit estimate, a rush of follow-up requests, and then either weather, faintness, or uncertainty widened the search region until it became a needle in a galaxy problem. And the reason it's gone depends on which of three failure modes happened. Each one tells a different story. Here's the main explanation. There are three realistic ways an interstellar object can seem to disappear. First, it faded below detection. You might be thinking, how can a real object disappear? Easy. Brightness isn't just size, it's distance, illumination angle, reflectivity, and whether the object is active. Something can dim fast as it recedes or as the viewing geometry changes, especially if it was barely detectable in the first place. Second, the orbit uncertainty exploded. This is the killer. If you only get a short observation arc, your future position becomes a widening cone. It's like trying to predict where a thrown baseball will be in 30 seconds after seeing 2 frames of video. The math gives you somewhere in this huge region. Telescope time is limited. Search regions are gigantic. The object becomes effectively lost. Third, it changed physically. Comets fragment. Surfaces shed dust. Outgassing can push an object slightly. Tiny force, big effect over time. Oumuamua famously showed non-gravitational acceleration that sparked ongoing debate about what caused it. NASA summaries and published discussions. If 3I Atlas was active or fragile, it could have dimmed, split into pieces, or deviated from a simple gravity-only path. So the satisfying answer is gone, usually means one of these three. But it raises a scarier question. If we can lose it this easily, how many interstellar visitors slip through without us ever noticing? Just when you think you understand, here's the twist. Sometimes the object isn't gone. Sometimes it was never a true 3I in the first place. Two complications can create chaos. The first is misidentification. A faint dot can be a satellite, a rocket body, or even an artifact, especially near the detection limit. If follow-up can't recover it, the discovery can collapse. That's not failure. That's the scientific method doing quality control. The second is a false interstellar signal from early orbit fits. Early on, an orbit can look hyperbolic simply because the data is sparse, and some objects can end up on hyperbolic-looking paths after planetary encounters. The gold standard is checking the object's barycentric orbit and long-term behavior, not just one quick fit. So you end up with a real controversy. Some people swear it vanished, others say it was never confirmed, and the truth depends on follow-up data that might not exist. I genuinely want to know what you think happened. If 3I Atlas is gone, which explanation is most likely? A. It faded, and we simply can't see it now. B. The orbit uncertainty blew up, and we lost the track. C. It fragmented or was misidentified from the start. Comment A, B, or C, and tell me what evidence would convince you. Because this matters. Interstellar objects are free samples from other planetary systems. They can tell us about chemistry, planet formation, and what kinds of material are common out there. And the same tracking tech is also planetary defense tech. Better surveys, better orbit determination, faster follow-up, better coordination. In the 2026 era, the shift is scale. Next-generation wide-field surveys and automated pipelines mean we'll detect more fast movers, but we'll also face more lost object moments unless follow-up gets faster and smarter. The hopeful part is we're improving the whole system. Quicker alerts, better orbit fitting, more global telescope coordination. Losing one object teaches the network how not to lose the next one. But this isn't the only space mystery hiding in plain sight. Next, we'll break down how astronomers compute an orbit from a handful of dots, how to tell a true interstellar object from a fake hyperbola, and the wild question, could we ever launch a mission fast enough to intercept the next visitor? Thanks for watching. Space doesn't need to hide things from us. Sometimes it just makes them faint, fast, and unforgiving. Stay curious and see you in the next one.